Hello everyone, Assalamu alaikum wa rahmatullahi wa barakatuhu. A wonderful day all of you. Welcome to our Institution of Global Professional Free International webinar. Every day is a good day. There is something to learn, share and celebrate. Thank you all for joining with us in this marvelous session, and I am Kamrul, coordinator of ICT from Bangladesh. Ladies and gentlemen, I am proud to be associated with IGP as a global member, and I feel honored to host this webinar, and it's my delight to welcome you all to our Institution of Global Professional Free International webinar. Once again, thank you again all for joining with us in this session, and I hope you stay with us till the program end. And time to time, you like our Facebook page and subscribe our YouTube channel for upcoming information. Every day, some new participants join with us, so I have to give little concept about IGP, Institute of Global Professional Search Community and Students Resource providing holistic social work and education for creative competent generation. IGP is a leading and online skill development institute with thousands of learners worldwide. Institute of Global Professional is an educational institution provides social work with globally recognized. We organize our webinar training, online and offline courses accepted by best and trained speakers and courses from all over the world. Before we have completed our 826 webinars successfully. Now I will be presenting webinar number 827, and the topic is determining the right statistics. Today we have a speaker from Philippines. Today our speaker name is Rafael Kevin. He is a head teacher one of Calibo Integrated Special Education Center, and he is a part-time associate professor of University of San Agustin, and he is also a part-time clinical instructor and lecturer at Auckland Polytechnic College. He is a part-time lecturer of Auckland State University, and he is Associate Council member of National Research Council of the Philippines. Let's welcome our speaker to the stage. Hello, sir. Good morning.
Hello, good morning, everyone.
Thank you, sir, for joining.
Welcome. It's my pleasure.
So give a short description about yourself, then you can start your presentation.
Oh, yeah, sure. Well, thank you so much for that introduction. I'm just so happy that I was well introduced. Everything there is actually quite already enough, I think. And I guess we can actually go on to our actual topic for today, right? Mr. Moderator. Okay, so, well, yes.
Yes,
So,
sir.
Carmel, we can actually begin the topic now, right?
Right, sir.
Okay, thank you so much.
Okay, sir.
All right. So, as mentioned, our topic for today are for people who are enthusiasts of research. Well, specifically, this will be focused on quantitative research as we will be dealing with statistical tools. So, our topic for today is actually all about determining or identifying the right statistical tool to be used in a quantitative or mixed method research. I know for sure that this is one of the areas for improvement of some individuals who are not quite accustomed with the mathematical structure of the research process. And this time we will make it a little bit easier because right now we have tools to utilize like technology in the form of software to measure. But the question is, which statistics are we going to use? With that, I would like to thank first the Institute of Global Professionals for granting me this opportunity to share what little knowledge I have. And this is me, Rafael Kevin Nagal, representing the Philippines, specifically the Aklan province. Okay, so let's begin our topic with what is statistics? As we all know, statistics are actually the scientific study of numerical data based on variation in nature. And of course, it's a set of procedures and rules for reducing large masses of data into manageable proportions, allowing us to draw conclusions from those data. So, from the entire population of, let's say, thousands or millions, we can get a sample of that and we can infer the data from them so that we can generalize the entire population. So, that is how good a statistical data is. Now, statistics is both the art and science of making decisions in the face of uncertainty. Right now, the uncertainty is, of course, the only thing that is constant in nature. So, statistics is the science of collecting, summarizing, presenting, interpreting data, and using them to test our hypothesis. So, we're talking about statistical hypothesis here, the null and the alternative hypotheses. Now, what are these statistical data? So, well, sometimes we use observation. So, these are actually the information obtained from a single person. Data, on the other hand, is gathered from a group of people. While statistical data, these are raw materials or facts of any statistical observations arising whenever measurements are made or observations are classified. As mentioned, this is a branch of science that deals with the collection, presentation, analysis, and of course, interpretation of data. Statistics or statistical tools can be divided whether they are descriptive or they are inferential. So, descriptive meaning they can actually describe a certain population. Inferential by means of a certain amount of individuals or samples, we can actually generalize them. So that actually includes your Persis R, Spearman Rowe, Anova, and other tests. So let's have a game first. Please identify whether the following observations or statements will utilize descriptive or inferential statistics. So number one, a teacher computes the average grade of her students and then determines the top 10 students. So please use the comment section to answer this one. Okay, I'm actually looking. All right. So number one, we have here Cindy. Cindy got it correct. So a teacher computes the average grade of her students and then determines the top 10 students. This is simply stating we are going to get the mean. So that is through the average grade. Number two, a medical researcher predicts the number of affected COVID patients after 6 months. Take note, the keyword there is predict. Okay, so is it descriptive or is it inferential? All right, Cindy also got it correctly. So prediction is actually the one that we use most of the time for inferential statistics like linear regression. Number three, a researcher studies the effectiveness of a new fertilizer to increasing food production. So here, one variable is being measured whether it's going to affect the other variable. Of course, this is also inferential. We have Anne Dolinog Makaya who got it correctly. And finally, a janitor counts the number of various furniture inside the school. So simply this is counting, and of course that is descriptive. We have Han Tamayo who got it correctly. So of course we will be using here simple frequency. Okay. Now take note that statistics is usually associated with quantitative research. So descriptive and inferential statistics were already well defined earlier through our examples. So let's move on. I actually mentioned a variable. So I know everybody knows that a variable is anything that can change. So it assumes different values or labels for different persons or objects under consideration. Let's take note, or let's take a look at this example. An individual is actually thinking for something to wear. So the individual would think, I want a dress. But what type of dress would that be? So that dress can be represented in several forms. These several forms are called your variables. So it could be two variables. We have the green and the pink dress. We can call that as bivariate. However, sometimes variables are not just two. Sometimes it's more than that. So we have multivariate variables. It's not just male or female. Sometimes it's level 1, level 2, level 3, level 4. So let's take a look at another example for the variable. So if you're asking for, or if you're courting a woman, you would actually want to generate a yes or a no, whether she loves you or not. And of course, we always gear towards the yes. Sometimes it's always certain if a woman would actually say yes. So, but we all know that some girls don't answer directly. Well, if the individual doesn't look good, she would actually say, I'm not yet ready. My parents are strict. Or studies first. That is, if you look like this. However, if you would look like this one, there will be a standard yes for everyone. I am just kidding. Okay, so a variable can either be dependent or independent. These are the major categories of variables. There are also other categories like your interdependent. We also have your antecedent. No? For independent variables, the one on the left, dependent variables are on the right. The cause is the independent, the dependent will be the effect. So usually the standard or the beginning will be the input, that's the independent, and the output will be the dependent. Take note that the independent variables are the ones that we manipulate so that we can generate the standards or the answers for the dependent variables. Now the relationship between these variables are usually studied in using the statistical tools. Now usually in the title alone of a study, you can easily determine whether this is the dependent or the independent part. So let's take a look at these examples of research titles. So the first one, the relationship between exposure to mass media and smoking habits among female students, you can actually easily determine which one will affect the other. So which one is the dependent, which one is the independent. So I'll give you 5 seconds to, or 10 seconds to determine which one is the dependent and independent among these titles. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I want you to take a look at the following legend. The independent variable are the one highlighted in green. The one highlighted in blue, those are the dependent variables. So in the first question, we can have exposure to mass media as our independent, and smoking habits will be the one that can actually be the dependent variable. Peer counseling, also the independent, and so on and so forth. Take note of number 3. There is no dependent variables because they are actually associated with the demographics. Now, let's take a look at another topic regarding variables. We have measurement. So measurement is the process of determining the value or label of a particular variable for a particular experimental unit. So A measurement can either be discrete or continuous. When you say discrete, the number is actually fixed. We can easily determine that. While continuous, it's usually infinite. Like, I want you to please take a look at the numbers 1, 2, 3, and 4 statement, and please answer as we go along. So for number 1 to 4, identify whether the following are discrete or continuous variable. So number 1, the number of positive COVID patients in a hospital. Okay, please type your answer in the comment section. All right. So, the number of COVID patients in a hospital is easily to determine. There's a fixed number, so we can say it's discrete. Number 2, body temperature of COVID positive patients in a hospital. All right, very good. So number 2, any answer? Number 2 is, of course, continuous. Why? Because the body temperature changes over time. And because of that, we can easily say that it's infinite. Number 3, monthly income of employees in a company providing COVID-19 vaccines. So if you could have noticed, the monthly income of employees in a company will actually change depending on the status, depending on the lates, on the absences, and of course, the data will be infinite. Finally, number 4, the number of vaccines donated by China in the Philippines. And this one is also discrete. Okay? Now, the types of variables according to measurement are either categorical or numerical. So when you say categorical, these are the variables that can take on numbers. Like for example, we assign numbers for male. Let's say male will be 1, female would be number 2. However, these numbers don't have mathematical meaning. It means that number 1 is not less than number 2 and vice versa. So they are like, we just assign them values, but they don't have mathematical meaning. There are 2 forms of this. It's either nominal or ordinal. So when you say nominal variables, these are the ones that we assign to things. Like for example, for sex, we assign 1 for male, 2 for female. For ordinal, this is a categorical measurement or variable wherein we assign according to order. Like for example, first, second, third, fourth, fifth. Now for numerical, so the complete opposite of categorical, these data have meaning as a measurement. So the numbers can be counted. So there are actually 2 types of variables in this category. We have ratio, the one that has the absolute 0 value. It means that there is a real 0 in it. While interval, on the other hand, doesn't have the absolute 0, meaning that the value can go back to the negative side. So a ratio, for example, that would be 0 centimeters for height. So there is no such thing as negative 0 centimeter or negative 1 for centimeters in height. So there is an absolute 0 there. That's a ratio. Interval, on the other hand, let's say temperature in terms of degrees centigrade, because we have negative values for that. Okay? So now let's go back. Let's go to the topic about which statistical tools to be used. Take note of this, that the statement of the problem or the research questions prescribe the statistical tools to be used. So let's take a look at this example. Or, when I say the research questions, they are actually the aim and the objective of the study. They are actually used interchangeably. So first question, what are the types of stress experienced by the teachers? Can somebody tell me which answer or which statistics can be used for this one? You may use the chat box. Mm-hmm. All right, so this one, we can actually just use descriptive statistics in the form of frequency. So the types of stress can be generated by that. The second question, what is the knowledge level of students in math? So we're talking about the level of knowledge already. So these will actually include the scores of our students. So in math, we can actually have here mean and SD2 or standard deviation. The third one, is there a significant relationship between the motivation and exam scores of students? The keyword there is significance. Okay, we are talking about statistical significance in this case. So it should be significant at a certain value, whether it's at 95% confidence level or at 99% confidence level. So when you say relationship, we're talking about the relationship between two variables. And in this case, we're talking about motivation and exam scores of students. The best statistics that we use would be inferential. If it's a parametric test, we use Pearson's R. If it's a non-parametric, we use the Spearman rule. The fourth question, is there a significant difference between the pretest and post-test scores of respondents? So if you could have noticed, we are talking about just one set of respondents, and we are talking about their pretest and post-test scores. So they are the same individuals. So here, we can actually use the paired t-test or the z-test or the Wilcoxon for the non-parametric test. The next one, is there a significant difference between the English test scores of male and female respondents? So we have two variables that we're going to test the differences, male and female. So they are not the same as the previous question. So in this case, we have to use the independent t-test, and the non-parametric equivalent is your Mann-Whitney U-test. So some other questions will actually generate the Anova, Manova, Ankova, and the Mankova. We will discuss them later on. Now, statistics, as mentioned, is either descriptives or inferential. So we talked about descriptives are things that allow you to characterize or describe your data set, describe them and in the face value. Okay, there are four major types of descriptive statistics. The first one, the first category or type are the ones that measure frequency. So we have percent and frequency count for that. The second type, the one that measures central tendency. So I know that it's very familiar. These are actually familiar terms. The mean or the average, the median, the one at the center, the mode, the one that has the most number. We also have the measures of dispersion or variation. So we have here the standard deviation, the variance, the range. Now, for measures of position, we usually utilize the percentile ranks and the quartile ranks. Usually, we measure the range or the ranks for non-parametric. For mean, we are actually using that for parametric tests. Now, inferential statistics include the following. Well, we have the t-test. It can either be independent, dependent, or one sample t-test. Anova can either be one-way, two-way, repeated measures, or factorial. Well, its other forms, no, or its variants include your Manova, Ankova, and Mankova. Anova, by the way, literally means analysis of variance. We also have correlation tests, Pearson's R. Okay, we have regression analysis. We have your multiple linear regression or simple linear regressions. We also have other forms of inferential statistics, such as your factor analysis, your path analysis, your discriminant analysis, and the non-parametric equivalents of t-test, ANOVA, and correlation. So take note that inferential statistics require us to do a sampling technique. Okay, so sample size and other assumptions must be met for us to utilize the parametric tests. If assumptions are violated, then we go to non-parametric tests. So, as mentioned, parametric tests, these are used for pure experimental. Usually we use them for, like, if you're doing a laboratory experimentation. It's preferred when all assumptions are usually met. If assumptions, either one or two assumptions are violated, like for example, the normality has been violated, then we use the non-parametric test. So what are these assumptions that we're talking about? So the assumptions include your independence, okay, the measurement, normality, linearity, and variance. So take note of the following. The data must be normally distributed. We should use a test for this one. Like we have your Kolmogorov-Smirnov or the Shapiro-Wilks. The sample should be randomly chosen. Sample size should be large enough. Sometimes it should be more than 30. Variance must be equal. Values are both measured in interval or ratio scale, not in nominal or ordinal scale. There shouldn't be outliers. So in general, we use non-parametric tests if the assumptions are not met. So how do we define a sample? Take a look at the picture. The one on the left, let's say that's the total target population. Let's say these are the people in the entire Philippines. The sample, on the other hand, the one on the right, these are the randomly taken individuals from the target population. So a chip of the entire population, that's a sample. So a sampling technique is like this. Usually it's systematic that we get some of the respondents from the total target population. So a sampling technique can either be non-probability or probability sampling. So when we use it in quantitative data, we have to ensure that the data was actually utilized or the samples were actually taken using probability sampling. It should be random sampling. If not, then we go to non-parametric tests. So examples of non-probability sampling will include your availability sampling. You just choose the people around who are available. Purposive sampling, you actually have a person or people in mind that you need to gather for you to test. Well, quota sampling, it's like you have to get like 100 samples, and then whoever comes first, these are the people that you're going to take as respondents. So we also have snowball sampling. Like for example, that's actually a referral system. So some other non-probability sampling are actually called the biased method of sampling, like your convenience. Okay, a voluntary response, snowball, quota sampling, judgment. If you use any of these sampling methods, you use a non-parametric equivalent of the parametric test. Now, if we utilize the probability sampling, then of course a parametric test should be used. So here are some examples of our probability sampling. We have simple random, your stratified, your systematic, and your cluster sampling. So let's take a look at this formula, the most common formula that people are actually talking about, the Sluggish formula. N stands for the population size. This lowercase n stands for the sample size. E stands for the margin of error. So actually, it's now the only record that I found stating that the person who owns this is Yamane. So that's why I usually call it as Yamane's formula instead of Slovin's formula. So the allowable error should be 5% provided the computed sample size should not be lower than 30. So the E there should be 5%. So let's take this one as an example. I'll give you 30 seconds to finish estimating the proportion of the following. So the researcher would like to conduct a study on administrators' performance in a state university in Region 6 from which the distribution of population of academic administrators were as follows. So take a look at these numbers. Okay, so we have a given total population of 70. So as mentioned, the standard error is actually 5%. So we turn it into decimal, and that is 0.05. So the solution would be as follow. 70, then the entire population. Then that's over 1 plus 70 times 0.05 squared. That will give us a total of 60. So your sample size would be at 60. However, we are going to stratify them according to the population, and the distribution would be as follows. Okay? Now, other assumptions test. Earlier, I mentioned one assumption test of distribution, if it's normal or not. If you could have noticed on the screen, we have here um, these lines and these lines. This literally means that those beyond these lines or beyond these lines are actually not normally distributed. So if it's like that, we violate the assumption of distribution, of normality. So the test that we are going to use, if it's more than 50 samples, would be one sample Kolmogorov-Smirnov's test. If it's less than 50 samples, then we use Shapiro-Wilkes test. Now, another assumption test is the equality of variance. This is usually done for Anova. Here, the assumption test is the Levin's test. So, the variance should be equal. Now, the third one would be the Bartless test for homogeneity of variance, also known as your Homosedasticity. In in a graphing paper or in a graph, it should look like the one on the left. If it's homosedastic, it means that they are actually aligned along that axis. However, if it's like a scattered graph like this one, then of course we could not actually see that there is homogeneity of variance in that. The box M test, or the equality of covariance, we usually do this for ANCOVA and MANCOVA. So if you could have noticed, if it's equal, if the covariances are equal, it should be on the one on the right. The graph on the left is like the covariances are scattered together, so the variables are not good. Now, the first test would be the t-test. The t-test can either be one sample, it can be used to compare your data, only one set of data, to the mean of some known population. For example, you want to know, like there is already a standard grade or score for mathematics for senior high school. So you compare the data set of your students to that standardized data. That's the one sample t-test. Now, independent t-test, for example, you are going to compare data from two separate non-related samples. Example, for sex, we have male and female. So the data from male are different from data from female. So we have two different samples. So we compare them. That's independent t-test. By the way, a t-test actually determines the significant difference of two data sets. So take note, only two data sets or bivariate data. Now, for dependent t-test, here, the data comes from the same group of people. Let's say, for example, your grade 10 students pre-test scores versus your grade 10 students post-test scores. So the data came from the same group of individuals. So these are grade 10 students. So the pretest, their pretest scores and their post-test scores are the ones being compared. So thus, we use dependent t-test. Okay? So a t-test, its variant would be the z-test if it's less than the required sample of 30. Now, ANOVA, on the other hand, if earlier I mentioned that t-tests are for bivariate data, ANOVA are for data that are multivariate. It means for two or more variables like civil status. We have married, we have single, we have cohabitation. So um, there are three groups in that. If it's more than, or if it's two or more, then we use the ANOVA. If it's one-way ANOVA, this is actually the one that we frequently utilize, the one-way ANOVA. So there is one that we are actually going to compare three or more groups along the same dimensions. So it's actually similar to the t-test earlier. However, it's more than two or three. Okay. The two-way ANOVA, on the other hand, well, let's explain it later. But we can actually see that the two-way ANOVA has two independent variables and just one dependent variable. So we're going to compare these two independent with one dependent variable. Now, the repeated measures ANOVA, for example, you're going to measure two sets of data with different variables, multivariates from different time frame. Like, for example, from 8 a.m. and then you measure it again at 2 p.m. and then you measure it again at 6 p.m. That's repeated measures. Factorial ANOVA is used when you have two or more variables and you want to explore whether there are interactions between these factors. So a factorial ANOVA compares means across two or more independent variables. Now, the non-parametric equivalent of ANOVA is the Kruskal-Wallis. On the other hand, the non-parametric equivalent of the t-test, if it's dependent, then we use the Wilcoxon. If it's independent, we use the Mann-Whitney U-test. Now for Manova, so this is actually designed to test significance of group differences, same with ANOVA. However, in this case, we are actually having a lot of other variables. Okay, so there are multiple dependent variables in Manova compared to the ANOVA. That's why it's called multiple ANOVA. So here is an example of the one-way ANOVA and the one-way Manova. So for us to take a look, the independent variables are on the left side. On the right, we have the dependent variables or the response. So for ANOVA, we can actually see that the level of education are the independent variable, whether it's secondary, college, or graduate school. While the dependent variable in a linear scale, we have your test scores. Now, if you could take a look at the Manova, we have one independent variable, meaning there's just one category, whether they are secondary, college, or graduate school. The same with ANOVA. However, we are going to measure the test score and the English proficiency at the same time. So there are two dependent variables here. So we use the Manova. Now, what about the two-way ANOVA? As mentioned earlier, if it's a two-way, we actually have two independent variables. The same goes with the Manova, two independent. And, well, unlike the ANOVA, wherein only one dependent variable is being measured, the Manova actually measures more than one dependent variables. Now, what about the ANCOVA? So here, the ANCOVA is somewhat similar to the Manova, only that one variable is considered a covariance. It doesn't really affect, it isn't the one that is being measured directly, but we are actually assuming that these covariance can affect the other dependent variable. So we usually measure that, or we usually find the covariance through the literature. So the multivariate analysis of covariance is like the Manova version of, the Manova version of the ANCOVA. Okay. Now, what about the correlation? So correlation actually is a measurement wherein we are trying to relate independent variable to the dependent variable, whether one variable affects the value of another. Let's say, for example, with enhanced knowledge, will the practice also enhance? So we actually relate whether the knowledge can also affect the practice. If it's a parametric test, we use the Pearson's R. If it's a non-parametric, well, if assumptions are not met, then we use Spearman rule. Now, for regression analysis, um, well, the regression analysis is actually used if the Pearson's R is actually significant. It means that we already established the relationship, that there is indeed a relationship between one variable and another. So the next step is for us to predict one value to another, and that is through the use of linear regression. So here we can actually predict the value of y based only on the value of x. A multiple linear regression is actually the one that we use to predict the value of dependent variable from given multiple independent variables. Now, other analysis or tools. Now, if, for example, there are a lot of variables that we are trying to understand its influence to one another, then we use the path analysis. The path analysis is used to describe the dependencies among set of variables. I'm going to show you something later on to illustrate this one. The same goes with discriminant analysis. So a discriminant analysis actually tries to predict something will happen based on the combinations of several variables, whether it's categorical or numerical variables. Finally, a factor analysis. Here, for example, your tool to measure knowledge is not categorized yet. Because of factor analysis, you can easily categorize which one are related and which one are not. So the one on the upper left, this one is an example of your path analysis. So if you could see susceptible versus incubation, there is a direct relationship. Incubation has a direct relationship to symptomatic mild, and recovered also has direct relationship with symptomatic mild. However, susceptible individuals may influence recovered individuals, but not directly. Okay, so that is a path analysis. The one on the right, this is an example of your discriminant analysis. So the answer here is whether we will be able to, or the individual will be able to pass the board exam or not based on the following values, whether he's male or female, her score, his age, and so on and so forth. Now, the one on the lower left, this one is factor analysis. So the data is here, the one on the right. Here, the factor number 4 is being categorized based on the indicators. So the common theme here will be the fear of social evaluation or peer evaluation. Now, going back to my premise, the SOP dictates the type of statistical tool. So for test for differences between two variables, we have dependent or related samples. The question would be, is there a significant differences between pretest and post-test scores of respondents? Well, the parametric equivalent will be the paired t-test or z-test. If it's non-parametric, we have the Wilcoxon signed rounds test. Now, for how about between independent samples? So let's say the significant difference between the English grades of respondents when grouped according to sex. So we can actually use the independent t-test or z-test, and the non-parametric equivalent will be the Mann-Whitney U-test. How about if it's more than two variables? Example question, is there a significant difference among the English grades of respondents when grouped according to year level? Or is there a significant difference among the English grades and math grades of respondents grouped according to year level? And is there a significant differences among the English grades of respondents grouped according to year level when their entrance scores are considered? And the fourth question, is there a significant difference among the English grades and math grades of respondents grouped according to year level when their entrance scores are considered? So the first SOP question can be solved using Anova. The second question can be solved using Manova. The third one can be solved using Ankova. And the fourth can be solved using Mankova. And of course, the non-parametric equivalent of Anova, we can use the Kruskal-Wallis. Now, what about the post-hoc test? I guess you have heard of this one. A post-hoc test is actually the test that we use after the Anova is significant, or the Mankova. So, the post-hoc tests would actually include the following. The Fisher's LSD. So the most popular, we have the Shifi and the Tukis. Okay. Now, what about if it's a non-parametric test? What post-hoc test can we utilize? Actually, we should just use a repeated Mann-Whitney U to determine which pairs are significant. Okay. Now, what about the test for relationships or association between variables? So, first question, is there a significant relationship between the motivation level and exam scores of students? So here we have two numerical data. The second question, is there a significant association between the sex and presidential choice of respondents? We have here two categorical data. For numerical data, we can actually use the persons are if we actually violate some assumptions, then we use the Spearman rule. So if the persons R is significant, then we can actually predict the value of motivation level. I mean, we can predict the value of exam scores based on the motivation level. So we use the linear regression. The chi-square and the gamma can be used for categorical data. So what about path analysis? As mentioned, we can actually see the degree of association for each of the variables if it's multivariate. So for example, this one, the parent's education actually affects the parent's income at 0.37 and indirectly affect the child's educational attainment at 0.08. However, parents' education does not directly affect the child's educational attainment. Okay, so this is an example of the path analysis. Now, what about for the test for predictions? Okay, so there are two questions. What is the level of knowledge of students for every increase in their level of motivation? Or will the students be able to graduate on time based on their sex, age, GWA, entrance exam scores, and marital status and income? So the first question can be solved using linear regression, and the second question can be solved using discriminant analysis. There is no non-parametric equivalent for this type of test. And that, ladies and gentlemen, is how we overcome the process of determining the right statistical tool to be used. Yours truly, Rafael Kevin Ainagal. Thank you for listening. Hello. I hope that everybody actually was able to understand, although I know statistics is a very hard topic to discuss. It's even one semester for a PhD or a master's student. The video after this, I think, will be available for everyone, right?
Yes, sir, you can. Your presentation is helpful for our participants about statistics. Thank you so much, sir, for your wonderful presentation. Can you hear me, sir?
Yeah, I can hear you. Thank you so much.
Okay, sir. Now we are going to our quiz competition, and after that we come back again with our question and answer session. Okay, sir? Dear participants, now we are going to our quiz competition, and today our quiz code is IGP quiz. The code is IGP quiz. Let's enjoy our quiz video. Dear participants, this is our quiz session time. You can join this session by slido.com, and the code is IGP quiz. You can also scan our QR code from the screen to join this session. And top 10 quiz competition winners get their quiz certificate after this session from our official Facebook page. Our Facebook page address is Institute of Global Professionals. I request everyone to join with your full name, which will directly print on your quiz certificate. And I also remind you that there is no relationship between quiz completion certificate and free international webinar certificate. After this session, we proceed to our Q&A session, and after that, we move to our certification process step by step. So I request everyone mention your friends in the comment box to join this live quiz session. After 1 minute later, we start our quiz competition. Now 36 participants already join with us. You can also mention your friends in the comment box to join this live quiz session. And to join this session, you have to go to slido.com, and after that, you have to put the code, and the code is IGP quiz. Then you can join this session. Dear participants, we start our quiz competition now. Our first question determining statistics is the main purpose of a spreadsheet. The statement is true or false. Option number one, the statement is true. Our next question is, what is the limitation of official statistics? Is it only a certain number of crimes are reported, or it doesn't establish cause and effect? Option number one, only a certain number of crimes are reported, is the right answer. Our next question is, in analyzing fingerprints, what statistics have not been determined? Is it the number of minerals required for individualization, or the statistics on partial meshes? Option number two, the statistics on partial meshes, is the right answer. Our next question is, descriptive statistics are a branch of mathematics or listing of data in a practical way. Option number two, listing of data in a practical way, is the right answer. Our next question is, what are the three methods of determining probability? Is it empirical, objective, and theoretical, or empirical, theoretical, and subjective? Option number two, empirical, theoretical, and subjective, is the right answer. Our next question is, what is the definition of the study of statistics? Is it the study of numbers and their properties, or the collection, evaluation, and interpretation of data? Option number two, the collection, evaluation, and interpretation of data, is the right answer. Our next question is, in statistics, what is mean the exposure data? Is it that exposes statistical results, or info that indicates the amount of opportunity for an event? Option number two, info that indicates the amount of opportunity for an event, is the right answer. Our next question is, whose department is responsible for determining the consumer price index? Is it BLS, that means Bureau of Labor Statistics, or NBER, that means National Bureau of Economic Research? Option number one, BLS, is the right answer. Our next question is, a manager studying the previous sales statistics as well as forecast is using material or information. Option number 2, information is the right answer. Our last question is, if you subtract the lowest score in a data set from the highest, you are determining range or data. I, option number 1, range is the right answer. Thank you everyone for your active participation in quiz competition, and congratulations of our top 10 quiz competition winners. Top 10 quiz competition winners get their quiz certificate after this session from our official Facebook page. Our Facebook page address is Institute of Global Professionals. Now we are going to our Q&A session. After a short video clip, we come back again with our speaker. Welcome back,
I
sir.
think I think it's either they understood well or did not. Kamrul.
Okay, sir, this is our Q&A session time. Dear participants, if you have any question related to this topic, you can ask the question in the comment box. Sir, our first question is, good morning, sir. The question is, why is it important to choose the right statistical treatment for our study?
Okay, good question. Well, the appropriateness of a statistical tool in your study will actually determine the robustness of the results of your study. So, for example, if you used a different statistical tool instead of the ones that was supposed to be prescribed for that certain statement of the problem, then your result will be not robust and it's not actually going to answer the research question. Finally, the research question and the results itself will not be conclusive. Thus, your chapter 4, chapter 5, and if you have recommendations, will be, I would actually say, it would be worthless.
Thank you, sir. Dear participants, we are still waiting for your question. Our next question is, if we are going to use the mean and standard deviation, is it sufficient for the interpretation of data?
Very good question. Thank you, Leia. Actually, it actually depends on your aims or objectives. As mentioned, the statement of the problem dictates or prescribe which statistical tool you will be using. So, if your research is actually only trying to determine the mean, the mode, or the standard deviation of something, then go with it. Go with just the descriptives. Now, if you want to know the statistical significance, statistical significant difference, the statistical significant relationships, and its further questions, then go for the inferential. So again, we always go back to the research questions as that prescribes or dictates which statistical tool to be used, whether it's descriptive or inferential.
Thank you, sir. Dear participants, if you have any question related to this topic, you can ask the question in the comment box. We are still waiting for your question. So our next question is, what are the methods of determining probability?
Well, you need to clarify that further whether we're talking about the probability when it comes to sampling methods or the probability of the p-value that we are having in each statistical tool. If we're talking about the probability of using it in sampling method, then it actually depends on our type of study. Most of the qualitative study will actually use the purposive sampling, and of course, that is non-probability. However, if we're talking about the probability, the p-value, the probability value and significance, then there are several forms of statistical tools to be used. Like, for example, the Anova, the t-test, and so on and so forth. The one that I actually mentioned during the um, entire discussion earlier.
Thank you. Our next question is, in research, where do we mention about the epistemology and theoretical perspective?
Good question. Well, epistemology and theoretical perspectives are actually the higher forms of the methodology. Like your methodology is actually being dictated by the theoretical perspective, while the theoretical perspective is still under the epistemology. The higher governing authority in a research is actually the epistemology, whether it's objectivism, whether it's subjectivism or constructivism. That's epistemology. Now, the theoretical perspective is the theory embedded in that certain epistemology. Now, usually, we actually mention epistemology and theoretical perspective once we mention the methodology that we are going to use in the research design or in the chapter 3.
Thank you, sir. Dear participants, we are still waiting for your question.
Mm-mm.
Thank you so much, sir. There is no more question. Thank you so much for your wonderful presentation and your question answer. Thank you so much. for sharing your knowledge and valuable time with our participants. Thank you.
Welcome.
Sir, what is your last and final words for our participants? So, what is your last and final words for our participants?
Well, just be sure to check whether your research questions would really be able to answer the phenomenon that you are trying to unravel in the field of research. I know that statistics is very hard. Actually, it took me a while for me to be able to understand it quite well, but you will through the process of doing research itself. So continue to be a global learner and a lifelong learner.
Thank you, sir. Dear participants, now we are going to our certification process. Let's we enjoy a video, then we come back again. Okay, dear participants, today our program name is determining the right statistics and the code is IGP 4943. The code is IGP 4943. Please note that code to download your certificate. The code is IGP 4943. Without code, no one is eligible for certificate. With code, you can claim your certificate anytime from our website. Our website address is eduigp.com. To download your e-certificate, first of all, you have to go to our website. Our website address is eduigp.com. After that, you have to enroll the today's program. And after enrolling the program, you have to put the code, and the code is IGP4943. Then you can download your e-certificate. After downloading your e-certificate, don't forget to celebrate with IGP checking. Thank you everyone for your active participation in this session. I hope you learn something new from this session, and we hope we'll meet together in our afternoon session. Thank you everyone. Stay happy and stay safe.